looking at quadrilaterals, right? And quadrilaterals are our four-sided polygons. And we're going to basically look at the big umbrella of quadrilaterals and the different properties of the specific types and names of quadrilaterals, right? So to start with, all right, here's our big category, our big umbrella is quadrilateral. So that's any four-sided polygon. Right, then we have a couple different options, right? So our first one, which we're gonna make like a flow chart, so to speak. Let me change colors. All right, so the first one we're gonna look at, let me make that, I'll try to make that a little bit bigger, thicker, there we go. Well, all right. So our first subcategory of a quadrilateral is what we call a parallelogram. And we'll talk more about a parallelogram in a minute, right? But then I can get even more specific. Like a parallelogram is a specific kind of quadrilateral, right? But I can get even more specific, right? And if I take that parallelogram, which we've all seen a parallelogram, right? Our opposite sides are parallel, so it kind of looks like that. I can get more specific if I take that parallelogram that's kind of slanted right now and make it go straight up and down, like nice and pretty, or in other words, give it some right angles. And if I do that, I get to our rectangle. All right. Or if I take that parallelogram and make all the sides the same length, which is not as pretty, I get to our rhombus. All right. And then I can take my rectangle and get even more specific. If I take the rectangle with all the right angles and I make it have all the same sides, right? That's going to be our square, right? And then if I take my rhombus with all the same sides, but then has the slant going on, and I straighten it up with right angles, that also takes us to a square. All right, so a square is like the most specific kind of parallelogram. Okay, now if I keep going, let's come on this side. Another type of quadrilateral, another subcategory for quadrilateral is what we call a trapezoid. All right, and a trapezoid, I'm not going to draw a picture yet just because it's kind of hard. Well, I guess I can. We will. All right, a trapezoid just has the one set of parallel sides. So it could look something like that, where our top and bottom there are parallel. But then I can get even more specific. And one way of getting specific is if we do the one that you're used to seeing, the one that's nice and pretty and, well, supposed to be nice and pretty and symmetrical. That's what we call an isosceles trapezoid. And again, we'll talk about that in a little bit. All right, but that just means that it's symmetrical. So my sides on the left and the right are the same. Right, and then another way I can get specific is if instead of the two sides, the non-base sides being the same, is if I kind of straighten it up on one side. So I put a right angle in there. And that's what we're going to call a right trapezoid. All right, and then we have one more subcategory for our quadrilateral, and that is a kite. All right, and our kite that you typically think of, like the kite you fly in the sky, it might look something like that. And we'll talk about those properties. And I only have one option for getting more specific for a kite, and that's if I make one of my angles here a right angle. And that's what we're going to call a right kite. All right, now this order here, that the way that I've written like our chart is important, right? Because you have to be able to visualize how you get more specific as you move down, right? But then there's also a couple ways of reading the chart in terms of sometimes, always, and never. All right, so in terms of going left and right, so if I try to read going left and right, so what I mean by this is saying that a trapezoid is sometimes, always, or never a parallelogram, or a parallelogram is sometimes, always, never a kite, right? Or a rectangle is sometimes, always, never a rhombus. Okay, so in terms of going left and right, it's always never, right? Because a trapezoid is totally different than a parallelogram. You never have a shape that is both a trapezoid and a parallelogram. You never have a shape that is an isosceles trapezoid and a right kite at the same time. So you can't go left and right. That's never, right? Another option is if I go down. So that's like saying a parallelogram is sometimes, always, never a rectangle, right? Or a quadrilateral is sometimes, always, never a trapezoid. So if I'm going down, it's sometimes, because a quadrilateral can sometimes be a parallelogram, or it could be a trapezoid. So it's not going to be always, right? But it is still possible. So it's sometimes as you move down. So as you follow the arrows down, it's always sometimes, right? And then the other option, our last option, is going up. And the only option we have left is always, right? Because a rectangle is just a specific type of parallelogram, which means a rectangle is always a parallelogram. A parallelogram is always a quadrilateral, right? Just because as you move down, you're getting more specific, but you're still including all the properties of what was above it. Okay, so left, right's never, down is sometimes, up is always. All right, so you got to be able to remember this chart and try to visualize this chart. All right, now we're going to dive into the actual properties of quadrilaterals, and we're going to use these properties to find missing sides and angles and pieces, or to be able to classify and name a quadrilateral as specific as we can. So to start with, we're going to start with the big category of parallelograms, right? So our parallelograms, in general, we have a bunch of properties going on here with parallelograms. Maybe. All right, so to start with, just kind of like by definition, when you think of a parallelogram, right, I'm going to try to write, should be able to write all these underneath. I don't know what this weird bar is. All right, but for a parallelogram, one property is that both pairs of opposite sides are parallel. All right, so if you think about your parallelogram, tempted, all right, I can label parallel lines with little arrows, right? And so the opposite sides are parallel, and then the other set of opposite sides are parallel. So we'll put two arrows, right? Because just like with tick marks, if they're they're not all parallel to each other, so we have to differentiate. All right, so both pairs of opposite sides are parallel, which also makes both pairs of opposite sides congruent. All right, and then just while we're reviewing, the symbol for parallel is like a double L looking thing. Like if I was going to say that AB is parallel to CD, right? It's that double line in between. And then our congruent symbol is the equals with a squiggle on top, right? So sometimes instead of telling you in words in your problem, they'll use the symbols, and you have to know what they mean and be able to label it on your graph, or go from there. All right, so we got both pairs of opposite sides are parallel, which makes opposite sides congruent. All right, and then we have diagonals. right? And your diagonals connect opposite vertices. So all of our quadrilaterals will always have two diagonals. So for parallelograms, your diagonals bisect each other. Ooh. All right, and so that means that they cut each other in half. All right, opposite angles are congruent. All right, so both pairs, I'm just gonna not write it every time, but opposite angles are congruent. All right, and then consecutive angles, that's back to back. So consecutive angles are supplementary, which means they add to 180. And that comes back from parallel lines cut by a transversal. You should have seen in math too. But any pair of consecutive angles is going to add to 180 for all of our parallelograms. All right, now that's all parallelogram properties. So we'll try to put a little box around it here without messing everything up. Then I'm going to move over here, just to save some space, to our rectangle. So a rectangle is going to have all of these same properties of a parallelogram, plus a couple more. All right, so my first thing I'm going to write is all of the above. Oh, no. All right, all of the above, so all 5 of these properties, plus 2 more. All right, first is that it has 4 right angles. And then more specifically, not only do the diagonals bisect each other, but the diagonals are also congruent. All right, and that's for our rectangle. So I'll draw a picture. And I'll come over here. Oh no, that was rough. Stop. Okay, I give up. You're going to deal with that. I don't know where that line's coming from. All right, so I can put my 4 right angles in here. Right, and that's how I differentiate. It has the 4 right angles, and then because it's all nice, pretty, and symmetrical, the diagonals are going to bisect each other, but also be the same. All right, so these diagonals are congruent. All right, and that's our rectangle. All right, we'll move over to, we'll move down kind of over here. Okay, and we'll work on the rhombus. So again, a rhombus is just getting more specific. So our first property is all of the above. It has all of the same properties as a parallelogram, plus a couple. All right, so to start with, all sides congruent. We're going to use some symbols here. So all 4 sides are congruent. All right, not only do the diagonals bisect each other, but they're perpendicular. All right, and our symbol for perpendicular is the upside down T. And the diagonals, I don't know if I can get this to fit. Guess I can make this bigger. The diagonals bisect opposite angles. So that's kind of a new one. All right, let me draw a rhombus for us. Try to draw a rhombus. All right, so there's a diagonal. There's a diagonal. So our rhombus, our diagonals are perpendicular. They cut each other in half, and they cut the angles in half. So that means that that angle and that angle are congruent. Now, because it's a parallelogram, opposite angles are congruent. So that means all 4 of these angles are the same. And then these 4 angles, we'll put 2 curves in because they're also the same. All right, and then our last parallelogram is our square. And our square, we don't have to write anything except all of the above because it includes parallelogram, then rhombus, and rectangle. All of these are happening in a square. All right, so your diagonals are congruent. They bisect each other. They're perpendicular. They bisect opposite angles, right? Opposite sides are congruent. All four sides are congruent. We got 4 right angles, right? And then consecutive angles are supplementary, all that stuff. Everything like that's going on, right? So these are the properties that you're going to use to solve problems, solving for missing sides and angles and being able to name quadrilaterals. All right, so trapezoids, we're going to kind of start with the same thing. So remember your trapezoid is kind of similar to a parallelogram. But instead of having both opposite sides that are parallel, you have exactly one pair of opposite parallel sides, right? And those parallel sides are what we call the bases of your trapezoid. All right, and then our only other property for every trapezoid that's out there is that you have exactly 2 pairs of consecutive angles that are supplementary. Uh-oh, can't spell. So exactly 2 pairs, all right, we're going to start abbreviating, of consecutive supplementary angles. Okay, and so what I mean is I'm going to draw just a generic, try not to do our other ones. All right, but you have parallel bases. So we're going to say those are parallel. And then we're talking about 1 or 2 pairs of consecutive supplementary angles. And this goes back to your parallel lines cut by a transversal, right? So this angle here, we'll call this angle A and B, right? If you ignore the other side over here, these are 2 parallel lines cut by a transversal. So this angle A and B, these are your interior angles, right? And they're on the same side, so they're your consecutive interior angles. So that means that A plus B is going to be 180. And then if you ignore that side and look on the right side, it's the same situation where they're your consecutive interior angles. So you have C plus D is going to equal 180, right? A and C don't necessarily equal 180, right? So it's got to be, the ones on the left, the ones on the right, between your parallel bases. Okay, and those are our properties for every trapezoid. And then we can get more specific. All right, so the first way we're going to get specific is like our nice, pretty trapezoid that you usually think of when you think of a trapezoid. All right, and so our first property is all of the above because it's got the same stuff going on as our, general trapezoid. But then more specifically, our non-parallel sides, or your non-bases, okay, so our non-parallel sides are congruent, right? So that means we have our parallel bases, and then our sides that aren't parallel are congruent. Okay, this is nice and pretty and symmetrical, which means that our diagonals are congruent. All right, so they're the same, all right? They don't bisect each other, but they are the same, right? And then our last option is that base angles are congruent. Okay, so base angles touch the bases. So we have 2 bases, so we have 2 sets of congruent base angles. So the first one we'll say is up top, so we'll put 1 curve in those 2, and then we'll put 2 curves in the bottom. So the top 2 that touch the base are congruent, and the bottom 2 that touch the base are congruent. All right, and then our right trapezoid is not super exciting, because the only thing we got going on here, aside from all of the above, is that it has two right angles, right? And specifically, those two right angles have to be the ones that are consecutive between, right? Because if this angle over here was a right angle, like if opposite angles were both right angles, it would no longer be a trapezoid. It would turn into a parallelogram, and specifically a rectangle or a square. All right, so there's our trapezoids. We got one more set, and then we're done. Kites. All right, so our kites are a little different. They're a little weird. All right, but our general kite, right, and that's looks something like this. Okay, the way that we can kind of define a kite. To start with, we have two pairs of consecutive congruent sides. Okay, so not opposite sides. Okay, opposite sides are not congruent. And you can even get specific, right? And you can say, but not opposite. Because if opposite sides were congruent, it would be a parallelogram. So we can label that those two are congruent and these two are congruent. So you have exactly two sets of parallel, or two sets of consecutive congruent sides. Sorry, not parallel. No parallel sides. All right, and then we have diagonals. Okay, so if you imagine making a kite, or like, cartoons that make a kite, they take two sticks, right, and they kind of make a cross with them, and they tie them together in the middle there, and then somehow put cloth or paper or something on the side. So your diagonals, they cross at a special angle, and that's a right angle. So our diagonals are perpendicular. All right, now we talked about if you have that nice, pretty symmetry, right? Then your diagonals are gonna like bisect each other. But these clearly don't both bisect each other, but one diagonal is bisected. So we'll say one diagonal bisects the other, right? Because I have like the top left, bottom left are the same, top right, bottom right are the same. That means that there is like a line of symmetry. Right? It's going to be symmetrical on like the top and the bottom, which means that diagonal going up and down here is going to be cut in half. It's going to be the same on the top and the bottom. All right. And then we got one more. All right. We have exactly one pair. Well, let me rewrite that. Nah, we won't. All right. Exactly one set. What was a pair? No, I'm changing up my vocab. Exactly one pair of opposite angles are congruent. Right, and again, that comes to the symmetry. So it can't be like the left and the right angle because they have different sides pushing them together. So then we have this angle and that angle. So the ones that are on the symmetrical one on both sides of your line of symmetry are going to be the same. All right. And we are almost done with kites. That's the gist of kites. But then we can technically get more specific with our right kite. And it's only got two things. So the first one obviously is all of the above. Right? And the second thing is that it has one right angle. And it can only have one right angle because if it has more than one, it turns into a different quadrilateral. All right? And that right angle has only one option. It has to be between one of your sets of congruent sides, consecutive congruent sides. Because if it was in between the two different length sides, that means that the opposite angle would have to be the same, and then you have two right angles, which now takes you into some sort of a parallelogram depending on everything else you have. All right, so the only option you have is that it's got to be either the between one of the sets of consecutive congruent sides. Right, so here are all of our quadrilaterals and their properties. Remember, as you get more specific, all right, like a square has all the properties of everything above it inside that chart, right? So your square has all the properties of a rhombus, a rectangle, a parallelogram, and a quadrilateral, which the only property of a quadrilateral is that it's a four-sided polygon. All right, and that is it for our properties of a quadrilateral.